Hello, everyone. Today we are introducing SLAYs, Structured LLM Guided Agents Yield Skills for the BLAST AI Research Symposium of Summer 2023. So the general idea of our research is based on the two existing factors in which RL models often have difficulty generalizing skills, while LLM improvements show promise in complex reasoning. So our goal is to apply the properties of LLMs to structure RL models' reasoning. This would be done by improving generalization skills in complex environments. In addition to past research, we have noticed LLM's impressive abilities with reasoning and decision-making for long-term goals in complex environments such as Minecraft. This, coupled along with past research in which traditional RL has demonstrated few-shot convergence before fine-tuning the RL model. So by employing natural language as a planning tool through prompt engineering, we can guide LLM-generated skills and actions for setting long horizon goals and obtaining achievements in complex settings.
We utilized grounded LLMs in our project, and grounded LLMs are machine learning models that are given context about our agent's complex environment. And we used grounded LLMs to explore deeper and more insightful prompting mechanisms that improve our agent's chance of success. We referenced the SAYCAN approach to implementing grounded LLMs, which involves encoding semantic knowledge about the model's environment into a large language model. Additionally, our project explored few-shot convergence, which is a phenomenon of machine learning and AI that involves learning skills based on minimal context. And we provided our model with context from the research paper, as well as prompting outlines instead of providing large amounts of data. And our project also expands upon existing methods by implementing a vector database to streamline the retrieval process for context, using natural language to match an achievement to a sublist of actions, and grounding an LLM in the rules of Crafter, as well as using chain of thought prompting to improve our results. Our goals include synergizing reinforcement learning with large language models to create a new field in AI that explores the synergy between these two, as well as achieving few-shot convergence, bypassing benchmarks, and promoting generalization for the future of AI.
So for the methods, we first focus on the doc retrieval. So our solution was to store the Crafter paper in a vector database using the LangChain conversational retrieval QA. So we store the embeddings of the Crafter paper in a vector database, and we use an LLM to make queries about the game using the Crafter paper as context. So like asking the model about relevant information to play the game and what actions it should take, provided a particular goal and the environment description, and then relying on the Crafter paper to take actions in the environment, so that which has a potentially higher rate of obtaining achievements. Then we move on to main prompting guidelines. So for the prompting, which is asking the model to provide actions based on the prompt that we provide, we provide the directives encouraging diverse behaviors and imposing constraints. So we encourage it to explore its environment while also imposing constraints, such as it might not have the necessary resources yet, or it might not have learned enough skills to complete the task at hand. And also we pass in the agent's current state, so its inventory and its environment description, what is there near the agent, nearby objects. And we also pass in the previously completed or failed tasks and achievements, so that the model knows what it succeeded at and what it failed at, and what achievements it unlocked, so that it can use those for making further actions.
Yeah, so now I'll be talking about the prompting format and the parameters we used in our prompting. So first of all, our prompting is based around conversational modules. So that would include the use of OpenAI's chatbot model instead of a more generic model like OpenAI by itself. And we also use conversational retrieval train for the retrieval. Also use the conversation class to do our prompts. So that means that we use repeated calls to converse.ask to generate our answers. And then to actually get the model to understand our prompt, we had to input the agent's current state, as Rohan mentioned, including the inventory, equipment, the position of our character relative to the nearby blocks and entities, and also time, health, and hunger bars. We also had to pass in a list of actions and skills for the model to pick from, and we wanted to make sure that this was based on the crafter action space so that we could actually use these actions and skills in the game. And finally, I'll be talking about this in the next slide as well, but we use chain of thought prompting to have reasoning before code generation. And then this could break down long horizon goals into intermediate steps. And so now let's talk about the iterative prompting mechanism we use to have our LLM output skills for us. So first, in our prompting, we described the desired long horizon goal that we wanted the model to achieve. And then after that, we use environment interaction to find ways to achieve that goal. And for the LLM, we asked it to break down goals into smaller intermediate steps based on the current state and inventory, because sometimes the LLM would output too complicated goals that it did not have the requirements or the knowledge to attain. And so we generated new prompts based on the agent's actions, achievement, and current state that would be more achievable and relevant for the current for the current game state. And so to do this, we ask smaller sub-questions to guide the model in finding the proper action. And then after that, we would use these outputs in conversational lines of code in successive prompts. And so then we would ask the model if once it's found an action that it believes is the next action to perform, we want it to ensure that it meets all the requirements to perform this action. And so the goal is to achieve goals in an unsupervised manner and complete as many achievements as possible.
So our model is unique because it obtains knowledge from reading the crafter paper, so it requires 0 training steps, while typical reinforcement learning methods require millions of training steps, which is costly and inefficient. And our model is able to adapt quickly to its environment and learn in a supervised environment, which demonstrates few-shot convergence. Next slide. So currently we're still trying to adjust our prompting to improve our results. And while we don't have any final numbers currently to compare to other models, our model is converging and it's able to choose appropriate actions from the crafter action space, which is on the right. So for example, if we give it a goal such as make wooden pickaxe, it's able to choose appropriate actions. So in this case, it's moving down, and also our crafter is a OpenAI gym environment, so the model is connected to the game, so it's playing the game while we're iteratively prompting the LLM. And our current prompting approach is based on Spring, which is an approach that allows LLMs to play open world survival games like Crafter. And this approach uses a directed acyclic graph where the nodes are the game related questions and the edges are the dependencies between questions. So now I'll be talking more about the graph itself. Next slide, please. So this is our current, these are our cycle of prompts, and we modified the original Spring prompts. So initially we give the model its current state and info, and also the list of possible actions for it to choose from. And then we go through this iterative cycle, which utilizes chain of thought prompting. And lastly, we ask the model to choose the best executable action and reply succinctly or say, I don't know. And this is important because it helps avoid hallucination.
For our model, we found that it had higher success rates on simpler achievements such as collecting wood and collecting saplings, and it posed a difficult. It was harder to attain difficult achievements such as mining diamonds and crafting iron pickaxes. And while we don't have exact results yet, we found that different prompting techniques that we used really helped. So our current prompting system is by breaking down the achievements into intermediate goals. And we intend to keep testing this prompting mechanism to find the best way to make the model work.
Overall, in this work, we use grounded LLMs to pass in the crafter documentation and to pass in the paper, and using document retrieval for reasoning and skill development. We study advantages of using a vector database to store and compare learned skills and context. In order to plan correct actions and based on long and short-term goals, we use ChatGPT 3.5 for exploration and skill learning, while using a vector database for storing and comparing learned skills and context to be used in future situations. As a result, show studies has the potential to perform better than most baseline reinforcement learning models on Crafter. For our impact in future research, this demonstrates the potential of using LLMs in reinforcement learning benchmarks. However, one limitation is that the model needs the context in a language description. We provide this by giving the model access to Crafter's confidential description of the environment and inventory state, but we are interested in the future of using different approaches in updating the environmental context. Opportunities for future research in LLM guided reasoning with chain of thought prompting to few and no shot convergence in projects that require less context. We are interested about researching this in the future. Before we end this presentation, we would like to give some acknowledgements. We'd like to acknowledge our research mentor, Rishi, for helping us with this project. We couldn't have get this far without him. And we overall like to thank the Blast AI staff for giving us this opportunity and finding us the API key needed for this model. Thank you for listening to our presentation. We will now be answering questions.